Okay. So like I said, we're going to knock out 2 sections today. The notes aren't really long, pretty straightforward. So will be the homework, I would assume. It's going to be a little bit of graphing and then a little bit of, y'all remember like interest problems and stuff like that. We're going to be looking at some of those. Tomorrow is when we really get into logarithms. Okay. Remember, y'all have Tuesday off. That's nice. You can relax, hang out. All right. Without a calculator, go ahead and fill in these 2 tables. One says 2 to the x, and one says 1/2 to the x. And I'll go ahead and give you some values here. Let's do 0, 1, 2, and let's do -1. Let's throw in -2 as well. And then once you're done with the table, plot them on a graph. But again, without a calculator.
Isn't that the most disappointing feeling?
What did she say?
I had like a really big sneeze coming, but then just nothing happened.
Wow.
Isn't that like the worst feeling on the planet?
No.
No.
Maybe others.
I wouldn't say the worst.
No,
I'm glad you're not sneeze.
I think walking in wet socks is definitely worse than that.
I don't think so.
You did get your results back, right?
Huh?
You did get your results back, right?
I mean, Knoxville Pediatric Associate says so.
Good old KPA.
He's got the receipts.
Yeah, I've got my papers.
Did they check your ask if there was a smirk?
What?
What does that mean?
It's an inside job. Caden's pediatrician.
Are y'all done
time he
with
checks
both of
it,
you?
we're close.
Okay.
Every single time he checks
We only have an hour.
Yeah, it says this.
Less than an hour.
This will verify the above has tested negative for COVID-19 and can return to work or school on 10/29/2020.
Do you finish this?
Woo!
I'll laminate it later for you.
Yeah. I want to like post it on my wall.
Anything raised to the 0 power is what?
1.
Okay, 1. Heard 0 out there a little bit. Okay. Anything raised to the 0 power is 1. Okay. If it's raised to a negative power, what do we do? That's from the last chapter. Flip it. In other words, we put 1 over and it becomes positive, which in other words, that's just 1/2. This is 7.1 and 7.2.
Exploring exponential.
Yeah, exponential models and then properties. Okay, So let's look at these two graphs that you've created. Okay, one of them hopefully looks like the one on the left, and the other one looks like the one on the right. Okay, very similar. Not necessarily, this one's scaled a little bit differently, even though I don't think any of us can really see those numbers right now. But if you notice, the exponential growth problem in our case was that 2 to the x. All right, and then our exponential decay problem, where we had the 1/2 raised to the x. Okay, so if you notice, exponential growth, b has to be greater than 1. B has to be greater than 1. We're using y equals a times bx. And if it's an exponential decay, it has to be in between 0 and 1. What's another way exponential decay can look like in terms of an equation? What's another way that we could say exponential decay? You got it? Yeah?
Maybe, but I don't want to be wrong, so.
That's okay.
Yeah, no.
Okay. What's another way we can write exponential decay that's different from what's up there, telling us that b has to be between 0 and 1. It's another way we can write out that equation that would show exponential decay. Not changing b, something with the exponent. Got it?
The fraction exponent.
Not a fraction exponent.
Rational.
Huh?
You make it negative.
It could be a negative.
Dang.
Because if we make it a negative, then that makes b a fraction, right?
Perhaps.
So that's why we could write it another way. I just wanted to, in case you saw two different equations, maybe one was y equals 1/2 to the x, or maybe you saw y equals 2 to the negative x. Okay? So if it has the negative x there, that's also going to be a decay. Okay?
Now, is that only when b is greater than 1?
Yeah, well, b has to be, yeah, if b was in between 0 and 1, then it would reverse the reverse, if you will. But yes, b would have to be greater than 1 in this case. Hello?
So does the same go for the other one?
I wouldn't manipulate that one. That's more of the exponential decay. I just wanted you to be familiar if you saw this and if you saw that they both imply decay. Okay? So, go through these 4 examples and tell me if it is an exponential growth or a decay. Just by looking at it. Okay, who's got my first one for me? Hey, Jonah.
It's a growth.
Growth. Why?
Because b is greater than 1.
Okay.
And the term negative than 1.
Who's got my next one over there, top right corner? Bill? Okay. Because B is less than 1 and greater than 0. Good. Okay, who's got my bottom left-hand corner? Okay.
It's, what, I forgot the word, it's growth.
Growth, but it's a fraction. But why is it growth if it's a fraction?
It's 4/3.
It's 1 1/3. They'll get you every time for those guys, okay? They like to put out fractions that, even though they are fractions, they're still greater than 1. So be careful. Did you have a question? You got the last one. All right, what's our last one? Growth. But I see a fraction.
But that's not the b value.
That's not the B value. Y'all are too smart.
Yeah.
I'm trying to trick you, and you just don't let me fall victim to it. Okay, any questions on those?
Yeah, I definitely would have either said something stupid or got one of those wrong. If it's
That's okay. I wouldn't have thrown anything.
2 hours earlier.
All right, so let's look at this guy.
Also, but it's not how you spell growth.
Growth?
Yeah, I was so close to saying that's not how you spell growth because I'm stupid.
No, hey, here's the thing. I probably would misspell something like that. Like, I'm the worst speller.
Well, you did misspell Sue a while ago, so.
What did I misspell?
You don't spell as bad as Miss Kissinger, it's okay.
But what did I
I
misspell?
was making a joke about soup.
Oh, soup. No, that wasn't me. That was Jenna, not me.
Miss Kissinger is the worst speller I've ever seen.
We need to send this.
I'll
video
send her
to
video.
Kissinger. Yeah.
I'll send her this video.
Like
Oh,
some finger
sorry.
bender.
Okay, so we've got this formula that is the compound interest formula. All right. So we are looking at A being our amount that we have after all of this. P is our principal. If you want to write down below the principal that this is your initial amount of money that you have, that's another way to say what the principal is. Like how much money you start off with. Then you have R, which is your interest rate. That has to be in decimal form. You have your N, which is the number of times it is compounded per year. Okay. So what that means is if I ask you figure out something or whatever, and it's compounded semi-annually, what number does that make you think of? 2. Okay. If you've ever heard of semi-annual sales,
Because it's like 6 months, right?
you would just put 2 in because it's years. Yeah. So if you have a semi-annual sale, okay, that happens twice a year. Okay, if they say annually, what number is that? 1. If they say quarterly,
4.
4. Okay. If they say monthly,
12.
12. And if they say daily.
365.
Okay. So that's what N is in this problem, okay? And then T, of course, is our time in years. So y'all, these problems are pretty straightforward. And what I mean by that is they're the best kind of word problems you'll come across. Hate word problems because I hate reading. We all know that. But these word problems that I literally can look at and say, that's what I need, that's what I need, that's what I need, that's what I need. Bam, plug it into a formula and I'm done. Okay, these are great. Yeah.
Where do you get the 1 from? Why is there a 1?
A 1? Oh, it's part of the formula.
Yeah, but like why?
Will you find out for us?
What?
Will you find out for us?
Okay.
Thank you.
I'll come in on like the last day of school or like in the middle of like finals or something. I'll be like, that's why.
Been
Please.
calculating it.
Don't do it in the middle of finals. Because they might like
Yeah,
X out your
Yeah,
test.
it's gonna be my thesis for like college or whatever. It's gonna be. why is there
Excellent.
one?
Listen, the one in the compound interest one. Nobody's ever figured this out.
Didn't you have you had to like prove that like 1 was bigger than 0?
Uh-huh.
How did you do that? How do you prove?
In
that?
a paragraph.
But like what?
You had to use like theorems and postulates and stuff like that.
Okay.
It just is.
I know, you couldn't be like, here's one apple and here's no apples.
What figure?
But that's literally
Yeah,
that's
yeah,
the answer. That's
It's like, by the theorem of blah, 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 like once you prove one theorem, then you could use it. Then once you prove that in another theorem, then you could use it. And then it's like, oh y'all, that class.
I'm gonna
was-
be
How do you
Talk about what you will not need
How do you prove a theorem? Do you just say like, yeah, it just is because there's.
by using
That's
other
why it's a
theorems.
theorem.
What?
But how can you prove
Well, then how do you prove those ones?
Exactly.
I mean, Neanderthal can be
The universe was created last
like
Thursday.
Okay, now there's another formula. Okay, so this one is compounded continuously. Usually, no? Too many U's? That's right.
I don't think
It
Ah,
looks
like
weird.
that's too
Yeah,
many.
I'm looking
Like
at
that's too many. Get rid of the first U.
I'm the worst speller of mankind.
I think that U's supposed to be an I, isn't
Bam!
it? Is that right?
Hey, there's no red line under it.
Well, it's not a red line under mine. The words I misspelled on my page. Does that mean they're right?
No, because I'm using a device.
This red line under
Okay, compounded continuously. A still means the same thing. How much money you end up with. P is still your initial amount, what you started with. E is a number.
Oh yeah, that's a constant, right?
Okay, and E is a number. All right. It is like 2.71828, something weird like that. It's irrational. It keeps going on forever.
What's the point of it?
R is still your interest rate, so it has to be in the form of a decimal, and T is still your time. So even in the word problems, it's really obvious to figure out which formula you have to use, okay? One will say compounded continuously. One will say compounded quarterly, daily, monthly, yearly, and all that stuff. Yeah.
Why is E a thing? Like what is it like? Like you know how like pi is a thing and it's like circles, right?
Uh-huh.
Why is E a thing?
Because it is.
What?
Whoa.
That I mean, is it like for any specific problem that they created it for, or is it just for like?
I'm not doing anything to you. I'm gonna see if I have my notebook back here.
Oh, I thought that you were like gonna point this out back there.
No, I
She
have
has
my
an
history of mathematics binder from college that I was just gonna let you read.
And the awards for the
Thank
most boring class goes to
100%.
the history of mathematics.
I could not agree with you more. It was like so and so invented this
Yeah,
number.
it's not even like the history of like the world or anything. It's about mathematics. Like it's not about like.
This is the
Yes.
This is the history of the alphabet.
I'm not actually gonna hand this to you because you can see all my math grades.
Yeah,
I saw it.
Yeah, I want to see how bad.
You saw a 63? Yeah. That was rough.
That's 5. That's not
Yeah, I said -5 though. How many questions?
Yeah, welcome to college. You missed 5 points and you fail it.
Yeah.
Oh, and a lot of them, to be honest, was misspelled words.
They also
I
have.
misspelled these weird mathematicians' names, and he was like,
They
minus
also
points.
have like
At some point, I would
the
just
10-point grading system, right?
So this teacher made us do page numbers, dates. We had to do table of contents, and then we also had to do a whatchamacallit, appendix in the back.
Index.
Remember an appendix. Remember?
you better.
We'll find this after. I've already got virtual kids that stopped listening.
My sister has like a 70 and she's like has a C in a class. So like isn't there like a 10-point grading
I
system?
think it's like professors, like if it differentiates for like professor in school.
So if you have the good professor, you just.
Okay, moving on.
Okay.
You went to the UTK, didn't you?
I went to UT,
Which one?
the University of Tennessee.
Which one?
The University of Tennessee. Okay,
Memphis.
London invested $530 in an account paying an interest of 2% compounded continuously. Bam. I've got the main stuff I need right there. I know I have the rate. I know I have my initial. I know it's compounded continuously. So assuming no deposits or withdrawals are made, how much money, the nearest $100, would she have after 16 years? Okay. So it says compounded continuously. So naturally, that's that PERT formula. Okay. So then I fill in what I know. Okay. My initial amount was $530. I have E. My rate, do I just plug in 2? 0.02. Remember, you moved the decimal place twice. And T is our time. How much time are we looking at? 16 years. So, you have your calculators? And virtual kids, I'll show you what's on my screen here in a second. So we're going to type in 530. Whoops. Okay. E is second. Look down where it says LN next to 4. Okay. See that blue E or whatever color it is for you? It's right next to 4, which is LN, but you have to hit second before you do that. Then we type in 0.02 and then times 16. So they are interested in the nearest $100. Let's just do normal money, okay, for these problems. How much money is she gonna have?
$729.87.
87
cents.
88 cents. 7 rounds to 7 up.
Oh, do they round up? I don't think they were like round down like every scenario.
No,
No, they're on it.
Well, yeah, I mean, like if she got the money, then they would round it down.
if I was given the money, of course it'd be rounded down because I teach high school.
That's 16 years and you got less than $200. Almost $200.
Also, I really don't think the bank's
Yeah.
gonna like.
And honestly, that's probably really nice. Because, like, if you've ever had a savings account and they're like, we're giving you interest on it, and you're like, woo, a penny. Thanks. Like, I think at one point, my old savings account, it was like, maybe I put like $200 in it. And it was like 200.03. I was like,
Yeah, you get like
Yeah, once it's supposed to
the first year you get like
Mike,
$10.
thanks, guys.
Yeah, the
Okay,
first year you get $10.
let's try this one. Red flag tells you it's compounded how much?
Daily.
Daily. So that's that first formula. Okay, plug in everything you know.
That's right.
What did y'all plug in for your daily amount for your N? What was your N value? 365. And of course, T is our time. So these problems are nice in the sense that once you have all of your information plugged in, you literally can only miss this if you plug it in the calculator wrong. So I would highly suggest on a test or quiz or something like that, plugging that in like multiple times, just to make sure you didn't forget the 0 with the 0.017. Make sure you didn't forget anything of that nature. Because I would hate for you to have such simple laid out problems like this and miss it just because you typed something in incorrectly. All right, so 360. We have 1 plus. If you have an older calculator, make sure you use parentheses. I'm going to try and type it in as if it is an older calculator. I know you can use the fraction alpha y equals, but just in case, then you would have to put 365 times 10 in parentheses as well, okay? So 426, they said, to the nearest $10, so $430. Let me bring this in so people can see that. If I was just doing money, I would say $426.71. Okay. A lot of times with money, they'll have you do the cents there. Yeah. Yeah. Woo.
What does compounded continuously mean?
It is just literally like it's constantly going. So it's only being compounded every day. Compounded continuously is it's just like nonstop. Do I? Someone said something.
$6.67 a year.
I like you finding out like this will be good because when you do get into the real world and you're like someone's trying to sell you on putting your money at their bank and you're like, listen, you're really only giving me $6 a year.
I put money in the walls on it.
Graphing calculator.
You're like, I'm just gonna keep it underneath my mattress.
All my money is involved.
Okay, so let me see here. We've got another, so this is compounded monthly. Let me see if I can get us, let's look at this one. All right, so Leah is gonna invest in an account paying interest of 6.9% compounded monthly. First formula. How much would Leah need to invest to the nearest $10 for the value of the account to reach $4,400 in 7 years? Okay, so we're now wanting to know how much money do I need to put in? Okay, so this would be a situation where you're like, I need to afford this car. Here's all the information that I have that goes with it. What do I need to put down at the beginning? Kind of deal. So now we have to get a little creative when solving. We can't just plug it in the calculator, plug and chug, and be done. Okay, so if we set this up, we want $4,400 in the end. We don't know how much we need to put in to get to that point. We have 0.069 as our rate. Monthly is 12. So this one's a little bit nicer because we have what we're wanting just being multiplied to a number, okay? So we can figure out what this is right here, this whole big piece, or we can make our life simpler and more accurate by just using our calculators. So if I know these two are being multiplied together, I'm just going to divide by that whole thing. If you want to, you could do the second entry if you wanted to solve that first and then do the second entry to figure it out. But me personally, I'd probably just plug it in the calculator and keep it as pure as possible for the answer, if I can do that. Oops. Okay. And they said to the nearest $10 again, which would be 18. But if I'm wanting to get at least $400 or $4,400, I probably need to bump this up to 19. Because if I just do 2,718, I'm not going to reach $4,440. Okay. So I need at least that much money.
Isn't the nearest
put-
$10 20?
I'm sorry?
Isn't the nearest $10 20?
I get what you're saying. Yes. Then it probably needs to be 20. I was going by $1. You're right. You feel like you win?
Huh?
You win one today?
I don't win.
I feel like that's a win.
What?
Sometimes students thrive off of correcting teachers, you know?
You're a human.
I just think it's fun.
I am a human, you're right.
I just think it's funny sometimes. Like correcting Brock is always really funny.
Oh.
Any questions so far?
How's your day been?
It's been great, thank you. I got to sleep in. I didn't have to like chug my coffee. Like I got to sit down and enjoy it.
I woke up at 9:40 and then left at like 10:15.
A good feeling on those cases. Okay.
I saw a fraction.
You did see a fraction.
I don't know.
Can we run away?
Let's look at this one.
Ask my question.
I'm sorry.
Go ahead and set this one up. Fractions aren't fun unless you don't have a calculator. When y'all have calculators, they're not as entertaining.
Yeah, they're boring.
Right.
Yawn.
I'm bored even looking at this stuff. I haven't found why E was created, but it did say that Euler in 1737 proved that E was irrational.
Oh,
Good job, big guy.
Yawn.
Well, good for him.
Right.
Yeah, he did it.
He really did.
These names are entertaining. Wansel. Gauss.
Dane, can that be the name of your children?
Huh?
I'm wanting Dane to name his children.
Should I name my child that?
I don't think it's
Yes.
my decision.
Wansel. Wansel Chapman.
I want to name my child John, just for the Q in the middle. It's still pronounced
What
John.
about Euclid?
Oh,
Euclid?
Jesus.
Euclid Chapman.
Do you think I can name Gorbachev without getting blacklisted?
What?
After the Soviet Union leader Gorbachev? Then completely after no, Reagan would roll around in his grave probably.
I feel like names are gonna get like stranger and stranger until eventually it's just gonna all loop
This
back.
one was named Playfair.
Names have gotten simpler and simpler, but I feel like it's a wave of like really simple names to really complicated names and then back to really simple now.
I mean, like, look at Elon Musk. X8.
Oh yeah.
I can definitely tell when y'all have gotten extra hours of sleep. Proud of y'all.
No, yeah, pronounce
Okay, so this is why we're gonna need this whole chapter. Okay. So looking at this particular problem, she is investing $390. We're compounded quarterly, so we are going to.
Hi, Mrs. Chapman. I just wanted to like.
That was not your message. Are you Mrs. Chapman? No, you're not. Okay.
why I was reading it for you.
I'm text to speech, bro.
Me and Jonah can just be your personal.
Excellent. Okay. Oh wait, so this is not the one I'm thinking of. That's why we need the whole chapter. So we don't know our rate. We know our time. Our quarterly is 12, and our time is 14. So we have to break this down one piece at a time. Okay. So with these particular problems, I understand y'all have a calculator. Okay. There are ways to, like I said, do Y1 and Y2, and you can figure some stuff out pretty easily that way.
Yeah, it says quarterly, not monthly.
Quarterly, not monthly.
Oh.
I'm on fire today.
Well, get some water.
Shut up. Shut up.
Anyways, I hope all of y'all that are still listening are very entertained. Okay, so let's take 810, and what's our first step?
Divide by 3 units.
Now, I would keep this in your calculator as much as possible, again, to keep your answer as pure as possible, okay? So if you want to write it down as you go, so 2.076 or whatnot, just so you can see what it looks like, then you can do that. But keep it in your calculator as much as you can. So then what technically would be your next step?
Get the 14 times 4 root is.
What is 14 times 4?
No, don't tell me. Shut up.
56.
I said don't tell me.
Okay, so then what I'm going to do is in my calculator, I'm just going to go to math, option 5, which has that X there for me. And I can type in 56 right there. Okay, and then I'm going to do it of my answer. So I'm going to do second negative. So now I have this. So people can see that. So then what would be my next step from there? I don't need the parentheses anymore. What did you say? Subtract 1. And then do what? Then multiply by 4. I misspoke when I said this is why we have this chapter. I'll go back over it here in a little bit. So we have 0.053. But if I want to know the interest rate, what would it be?
5.3%.
5.3%. Okay,
Yeah, I'm at.
so there's actually the whole problem there. I'm just going to move the decimal place twice to the right. So 5.3%. Okay. If you need to write it down on your paper, go for it. But like I said, keep it as pure as you can and not go with a rounded answer each time you start doing more things.
I like this because I feel like I'll actually probably use this in my life.
You feel like you actually will?
Yeah,
Good.
thanks.
I've done one thing right.
Money.
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 All right. What I want to find. Did I miss that? Guess I didn't have one of those. So what I thought I was getting with, I guess I don't have one of them up there, is when we start getting the variable in the exponent, okay? That's why we're gonna need logarithms. All right, so our main goal, and you'll see these problems reappear at the end of the chapter, and that's gonna be because we're gonna solve for time, okay? And so what that does is that then creates us having to use a logarithm to make that happen, okay? So, real quick, I know we have about 7 minutes. Go in your calculator real quick. And remember we kept doing stat and stuff like that? Okay. Go into stat. And notice how in this particular question right here, it says find an exponential model. Go to calc. And you will see down there at option 0, you have exp reg, okay? So that's what you'll use for an exponential regression right there.
Pretty accurate.
Okay? So again, those we've done before, we'll plug in all of our values and then we can answer that. Now, another thing that's just the same, you might want to put this in your notes. Transformations, they're the same things, okay? But you might want to see where they're coming from in a different formula, if you will, or a different equation. So the negative in front, same as it's always been, is your reflection across the x-axis. The number that's in front of the base, not the base. Notice how there are no arrows pointing to the base, okay? The number in front of the base is going to be your vertical stretch and compression. Base, there is nothing to that, okay? There are no transformations with the base. If there's a negative up in the exponent with x, that's a reflection on the y-axis. H is still your left and right. You go left if it's positive, right if it's negative. K is still your up and down. If it's positive, it goes up, and negative, it goes down. Those have not changed. Okay. So the parent functions vary when it comes to exponentials because the base varies, all right? So I could have 2 to the x, I can have 4 to the x, I can have 1/4 to the x, I can have all of that, okay? Let me show you one quick example. Let's do something like this, okay? Your parent function is just the base and x. Everything else is a transformation. So what is that -4 tell me my graph's going to do? It's going to go to the right 4. So then my parent function is 2 to the x. That's going to be what I graph. So if I think about it, if I plug in 0, I'm going to get 1. If I plug in 1, I get 2. If I plug in 2, I get 4. If I plug in 3, I get 8. If I went backwards, I plug in -1, I get 1/2. And it gets smaller from there. There is a horizontal asymptote that graph won't cross at 0, okay? Unless you have transformations. So then all we have to do now is move every point over to the right 4. And I still do not, well, I kind of did there, do not go below the x-axis, okay? There is a horizontal asymptote there. What would change the horizontal asymptote?
Leverage.
What?
What? Leverage?
Yeah.
What?
What transformation would cause this asymptote to move up and down? If the graph shifts up or down, so does the asymptote, okay? So it always stays at 0 unless you have to go up or down. That moves with it, okay? So if it was up 4, you move it up 4. So now there's a horizontal asymptote at 4, okay? So that one's just a little bit different. Okay, so tonight, let me go ahead and stop sharing.